everybody, and welcome to lesson 4 of trigonometry, angles, and ratios. So today we are looking at solving simple trigonomic equations. So they give us a really nice step-by-step guide right here, and I'll just walk you through it a little bit. So we are going to learn the concepts that we used about reference angles and the signs of the trigonomic ratios. So that was the different quadrants, the memorization tool, add sugar to coffee, or the cast rule to solve these. So an example here is solve sine theta is equal to 0.5, where we are looking in a range of 0 to 360 degrees. So the first step is to determine the quadrant that the angle will be looking at the sine. Determine the quadrants the angle will be in by looking at the sign of the ratio. So in this case, sine is positive, so that's going to tell us that it's in two different quadrants. We're actually going to solve this down at the bottom here, so I'll just talk through this quick. Step 2 is to determine the reference angle. So when we type that into our calculator, sine theta equals 0.5, we will be finding the reference angle. And if you draw a rough sketch, you can determine the rotation angle using the reference angle. We've done that already. So let's actually just get in and do an example here. You're going to see this, so just be careful. You always check the given domain to determine which quadrants are valid for the calculation. For the first few, we're only going to be using 0 to 360, but they could limit it to 0 and 180, 90 to 180. They could even go 0 to negative 360 and go around the quadrants in the clockwise direction or backwards. All right, so let's use this procedure. So we are going to solve sine theta of 0.5. So if we just write this down quick, remember, add sugar to coffee. Those are our four quadrants right there. And we know sine is going to be positive in, wow, that is massive. Hang on. Sine is going to be positive in quadrant 1 and quadrant 2. So we are looking at, let's make that a little smaller. Quadrant 1 and 2. And now we just need to figure out what sine of 0.5 is. So we are going to use the second function. So some calculators have the second, some will have a shift. You have to figure out how to type this into your calculator, but you should be able to do sine to the negative 1 of 0.5. And that will give you your theta value. Right? So theta equals that, which in turn equals, let me grab my calculator here, 30 degrees. So this is our reference angle here. And if I draw a quick sketch, let's move this over. I'll put this down here. So if we were to draw a quick sketch, it's going to be 30 degrees in quadrant 1 and quadrant 2. So that's the reference angle. So let's use red here. So 30 degrees looks something like that. 30 and 30. But we know that we want to find the rotation angles. So the angles we're going to be looking at, well, the rotation angle of, let's use maybe blue here, of the first one is just going to be that little section. So that will be 30 degrees. And the rotation of the next one will be all the way around, starting from the positive x. So that would be 180 minus 30, which would give us 150. So within this domain, we sine theta of 0.5 is going to be equal to 30 degrees or 150 degrees. Let's try that process again for sine negative 0.8090. So we know that sine, it's a negative value now. There's that negative there. So sine is negative in quadrant, that's 1, 2, 3, and 4. So sine is negative in quadrant 3 and quadrant 4. So we are looking for quadrant 3 and 4. We are going to type that in. So theta is equal to sine of negative 1, or second sine, or shift sine of negative 0.8090. And we get a reference angle of 54 degrees. I like to draw a quick sketch here. So 54 degrees will be in quadrant 3 will look something like that. And in quadrant 4 will look something like that, where this is 54 and this is 54. And now we want to find the rotation angle. So for the first one, so x is equal to, for the first one, we are going from, we go all the way around to 180, and then we add 54. So it will be 180 plus 54, and that will get us 234. And the second one, we are going, you can measure it if you want as 360 subtract 54. So 360 minus 54, and that gets us 306 degrees. So there's our answer right there. All right, I need to make this a little smaller here. Let's do cos negative. So the same value, but with cos. So we know that cos is negative in quadrant 2 and 3. So we're looking for quadrant 2 and 3. And we know that the reference angle is going to be shift cos, or second cos, negative 0. Oh, that's messy. Hang on. 0.8090, which gives us a reference angle of 36 degrees if I type that in my calculator. So a quick little drawing here. 36. The reference angle in quadrant 2 is from the nearest x, so it's going to be right there for 36. And in quadrant 3, it's the nearest x-axis, which is right there for 36. So the answer in this case is going to be, let's do it up here, 180 minus 36 and 180 plus 36. So we get 144 and 216. And last but not least, tan of x is equal to negative 2.4586. So let's see if we can give ourselves some space here. So tan is negative in quadrants 2 and quadrants 4. So this is going to be a little bit of a weird one. Quadrants 2 and 4. So we're looking to find the reference angle. So we are going to inverse tan to get 68 degrees. 68 degrees. That's our reference angle. Sorry, I'll write reference angle there. There we go. Wrong button. Reference angle is 68 degrees. I like to do a little sketch just so I know what's going on. It's good. I'm a visual person and I like that. So we are 68 degrees from the nearest x-axis in quadrant 2, which will be something like that, just a rough sketch. And then 68 from the nearest x in quadrant 4 will be something like that. So to find that, rotation angle, we are going to say, well, the first one is 180 minus 68, which will give us 112. And the second one is 360 minus 68, which gives us 292. Oh, hopefully that's making a bit of sense. Let's move on. We've got a couple more examples and then one more small section where we're changing the domain a little bit. So the next one, these are some just some weird cases. So let's just throw up put this right here for now. So we're looking for sine of +1, which means we are looking in quadrant 1 and 2. And if I do the sine to the -1 of 1, that gets me a reference angle of 90 degrees. So we're looking at 90 degrees from, let's do a little drawing here, in quadrant 1 and 2. So 90 degrees from the nearest x is going to be from here. It's going to be right there. And from here, it's going to be right on the same line. So you can see we're only going to have one reference or one rotation angle here. So in this case, that one is just going to be theta is equal to 90. Cos of 0, this is also kind of a unique one. So cos of 0, let's actually pull this back over, sorry. If we're talking about cos of 0, 0 is kind of on the verge of, or kind of like the edge of positive and negative. So in the positive quadrants, cos is going to be positive in quadrant 1 and quadrant 4. And if we do, so I'm just going to treat 0 like a positive value, and I can type that in. So find our reference angle. Cos to the -1 of 0 is going to give me a reference angle of 90 degrees. So if we look at 90 degrees from the x in quadrant 1 and quadrant 4, I'm going to get that right there, 90 degrees, and that down here, 90 degrees. And you can see that kind of makes sense. If 0's on the verge between positive and negative, on this side of the, oh, that's not what I wanted to do. In quadrant 1, it's all positive for cos, and as soon as I cross this line, it gets negative. So that represents kind of that barrier between the positive cos values and the negative cos values, and the same going this way, all positive cos until I cross this line, and then I'm into negative cos values. So that makes sense. So I still have two of them, and you can see that we know that this is 90 degrees and this is 270 degrees. So our reference angles are, or our rotation angles are 90 and 270. All right, a couple of things for this next example. We actually have an equation, 3 tan theta plus 1 is equal to 4, and they change the domain here from 0 to 180. So the first thing we can look at is we're only going from 0 to 180, so we're only using the top two quadrants, right? We know that. That's 0 to 180. So in this case, we are only looking to tan. Oh, wait, we got to figure out what tan. First of all, we need to solve for tan. 3, I'm getting ahead of myself here. We need to figure out if tan is a positive or a negative value. So we just need to do some algebra here. Subtract 1 to both sides. I'm left with 3 tan theta is equal to 4 minus 1 is 3. I'm going to divide both sides by 3. Cancels, and I'm left with tan theta is equal to 1. So tan is a positive value, which means that we are looking at quadrant 1. So normally we would look at quadrant 3 as well down here, but our domain is limited to the top 2 quadrants, so we are just looking at quadrant 1 only. So I can type this in. Tan to the negative 1 of 1 is equal to 45 degrees. So that means it's 45 in quadrant 1, which quadrant 1 is the nice one because that means that the answer is 45 degrees. All right, that's the first section. We are going to move on to solving equations outside of the domain 0 to 360. So when this happens, you can solve the equation using this domain, just like we did in the last few examples. And then using the idea of coterminal angles, you can either add or subtract 360 degrees or multiples of 360, depending on how many rotations you're going to do and in which direction. So we'll talk a little bit about that in our examples. Here we go. So we have this fun equation, root 3 tan theta plus 1 is equal to 0. And you can see our domain is 0 to 720. So what we're doing is we are looking at answers for not only one rotation to 360, but a second rotation to 720. So first we're going to solve for 0, to 360. We're going to solve that as the way we normally do, as if we are looking at one rotation for our domain, 0 to 360. So we just need to solve this for tan to figure out what quadrant we are using. Add sugar to coffee. So let's use some algebra here. We're going to subtract 1. So we have tan theta, root 3 tan theta, I apologize, is equal to negative 1. And then we're going to divide by root 3. And that cancels out, and we are left with tan theta is equal to negative 1 root 3. So in this case, we are looking at quadrants. Negative tan value is going to be quadrants 2 and 4. Quadrant 2 and 4. So in this case, if we find that tan value, so we are going to do tan to the negative 1 of negative 1 over root 3, we are going to get 30 degrees. So 30 degrees in quadrant 2 and 4 are going to look something like this. 30, I drew them a little bit close, didn't I? Sometimes sketching. My sketches are bad. 30 degrees there as well. And so we know that our rotation angles are going to be, this one up here will be 180 minus 30, so we get 150. And this one in the fourth quadrant will be 360 minus 30, and we get 330. So we're halfway done. We've solved everything for the first rotation, but we know that we are going to have to not only measure this angle and that angle, but we have to go all the way around as well. Let's just zoom in. So they want us to solve for, if we go all the way around to 360 and then like that. So how you can do that is you can say, okay, well, the next one is going to be, well, we know that this section of it right here is 150, right? And the rest of it, the other section of it, this part right here, is just a full rotation. So we can say 150 plus 360, and that'll get us 510. And then we can do the same thing for the other angle. Because now we're going to go all the way around and to here. So we know we've already calculated this section of that measurement. We know that that's 330. So we got to do 330 plus 1 rotation of 360. So 330 plus, I'll do that down here, 330 plus 360, and that will get us 690. And that's the answer. So we have 2 rotations, and within each rotation we have 2 answers, so that means we should have 4 answers total. Okay, I'll do one more example and then we'll get going here. Okay. To the nearest whole number, solve the equation cos x is equal to negative 0.82. But in this case, we are going from negative 360 to 0. So we're actually going negatively around the quadrants here. So if we wanted 0 to 360, we'd go this way. But in this case, we want negative 360 to 0. So we're going this way. But anyways, cos is negative, so we are dealing with negative cos, means we are going to be in quadrants 2 and 3. So again, we can solve. So the best way to do this is solve for 0 to 360, just like we would regularly solve. So we're working in quadrants 2 and 3. We can type that into our calculator. Cos to the negative 1 of negative 0.82 gets us a reference angle of 35 degrees. Now we want to find the rotation angle. So that's going to be 180 minus 35 and 180 plus 35, and that gets us rotation angle 145 and 215. So in the example above, we were going one more rotation around the quadrants and we were adding 360. In this case, we are going a rotation in the opposite direction, so we are going to subtract 360. So our next step is to solve for negative 360 and 0. So what we're going to do is we're going to take our answers from over here, and we're going to subtract 360. So 145 minus 360 and 215 minus 360. And the answers we get are negative 215 and negative 145. And that makes sense because if we start here and we go this way, that's going to be negative 145. And if we do the same thing but all the way to here, that will be negative 215. And that's our answer. Okay, that's it. Thanks for watching. Don't forget to like and subscribe.